This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs. Also, make sure to check out and subscribe to our YouTube original channel, UCTV Prime, available only on YouTube.
Good evening and welcome to the Jeffrey B. Graham Perspectives on Ocean Science lecture series. My name is Nigella Hilgarth and I'm the Executive Director here at the Birch Aquarium at Scripps Institution of Oceanography at UC San Diego. And it's my great privilege and pleasure this evening to introduce Dr. Walter Munk. Walter is so distinguished, has done so much, that I would take up till midnight telling you about him and still not do justice to him. So I'm going to say very briefly that he's Professor of Geophysics Emeritus here at Scripps Institution of Oceanography, and he holds the Secretary of the Navy, Chief of Naval Operations Oceanography Chair here at Scripps Institution of Oceanography. His awards are numerous. Probably one of the most recent and most exciting awards was the Crawford Prize, which was from the Royal Swedish Academy of Sciences in 2010. That is really the equivalent of a Nobel Prize. And that was for his contributions, his pioneering and fundamental contributions to our understanding of ocean circulation, tides and waves, and their role in the Earth's dynamics. I think the most important thing I can say to you about Walter is that he is among the world's greatest physical oceanographers, not only in this century, but in the last century also. An incredible, incredible achievement, and we are very privileged to know you and to have you here tonight. So please join me in welcoming Walter for his presentation entitled Where the Swell Begins.
Well, thank you, Nigella. I'd like to introduce the audience to my co-author, Cher, and her husband, Steve. Cher did the painting. And Cher's responsible for the first and last slide in today's talk. Cher started, and her husband builds the beautiful Pendoflex surfboards, her husband Steve. Cher has had a passion for riding waves ever since she was 8 years old, I think, and has surfed all over the world. And here is the slide of Cher in California, Mexico, Hawaii, Australia, New Zealand, South America. And what's most remarkable accomplishment is in 1970, she placed first in a combined men and women competition, in international competition. And when Cher tries to make up her mind where she wants to go surfing, she goes online on something called the Surfline. And here you are, the Surfline of today, and the waves are pretty crummy. It Scripps are like 2 to 3 feet. But notice on Thursday at Black's Beach, which is particularly sensitive to west-northwest wave direction, it's going to have breakers at 5 to 7 feet. And so I suspect that after looking at that, we're going to find Cher surfing Black's Beach this coming Thursday. It wasn't always like this, that you could go online and find out what the surf's going to be like. And I'd like to take you back to 1939, when I had just finished my junior year at Caltech, and came down to Scripps to work here for the summer. I wish I could tell you that it was love of oceanography. It wasn't. I was dating a girl whose grandparents were living in La Jolla, and I needed a job. And we spent a wonderful summer here. We ate abalones that we picked off the Scripps Pier at low tide for breakfast, lunch, and dinner. I haven't been able to eat abalones ever since. Now here's a picture taken at the time, not a very good picture. You see the incoming swell, which is the subject of my talk, but you see Scripps in the foreground, and then there were a few summer cottages towards the cove, and nothing in between, 2 miles of totally undeveloped land. And the next slide will show you Harold Sverdrup, who was the third director of Scripps, who was then director of the Scripps Institution, which consisted of 15 people, 15, not 50, including the gardener. So the Scripps Institution has grown by a factor of 100. We're about 1,500 people now. And it was a wonderful summer, and my romance with my girlfriend ended, but I'd fallen in love with Scripps. And I've been in love with Scripps all my life. And I was back next summer asking whether Harold Sverdrup, the director, would take me on as a teacher. And he said nothing for 10 long seconds, the longest silence in my life, I think, and then said, well, I suppose so, but I want you to know that I cannot think of a single job that's going to open up in the next 12 years. And I quickly said, I'll take it. And you see, the situation was that the only jobs in oceanography were at Scripps, at Woods Hole, in Seattle, and in Monterey. And so you had to wait for someone to die before you could go and find a job. Well, that was a very difficult time. This was 1940, and the country from which I come, Austria, had been occupied by the Nazis, and I thought that we all would be at war almost immediately. And I went up to Seattle to join the ski troops and served in Seattle for about a year and a half. And nothing really happened. There was no war, and I'd served my term. And Roger Bell and Harold Sverdrup and Dick Fleming started an activity here at Point Loma at the Navy Laboratory. It was then called the Radio and Sound Lab, to learn something about submarine detection, ASW, anti-submarine warfare. It was, the Germans were sinking our merchant ships at a frightening rate, and something had to be done about anti-submarine warfare. And many of the things that are so well known now, like the deep scattering layer and the convergence zone and things of that sort, were discovered at the time. And I came and joined that group. I was very fortunate. It was 1 week before Pearl Harbor, and all discharges were canceled. And I would have not been able to join that group if I'd stayed a week longer. A few months later, I found myself working in the Pentagon and learned that the Allies were planning an amphibious landing, the first initiative of the Allies, who were at that time losing the war. They were planning a landing in Northwest Africa, And I went down to South Carolina and observed some landing exercises. And when the waves exceeded 5 feet, the landing craft, shown at this slide, LCVPs, landing craft, vehicle and personnel, would be swamped, filled with water, people would get hurt, and the exercise would be canceled until a future day when the waves were lower. And I went home, went back to the Pentagon, and looked up some literature and found that in the winter in Northwest Africa, the waves on the average exceeded 6 feet. And it seemed like a catastrophe about to happen. And I was wondering, what in the world are you going to do about a situation like this? And thought the only thing you could do that made any sense is to learn enough about waves so you could predict it, and then pick a few good days, a few calm days. And so the prediction would consist of 3 parts: sea, swell, and surf. Sea, on the upper paddle, is the generation of the waves in the storm area, and the wave height that you generate depends on the wind speed and the wind fetch, the fetch being the distance over which the wind blows to generate the waves. Called sea. Swell is the problem of what happens to the waves when they travel from a storm area to a distant beach. And surf refers to the modification of the waves as they come into shallow water and break, probably the most difficult of the 3 steps for prediction. But anyhow, I thought it would be very important to learn to do that. To the best of my knowledge, it had never been done. And I went to the commanding officer and asked him whether he would let me go and do some work on trying to predict sea swell and surf for the benefit of the forthcoming landing operations. And I was 25 and I had absolutely no track record. And he said, no, you go back and do to what I assigned you. I said, but what's going to happen if they come in on a day with high waves? And he said, they have surely thought about it. And I've since learned there wasn't any they. There is, however, a very interesting letter somebody pointed out to me. Roosevelt and Churchill were both good boatmen, good yachtmen, good sea people. And Roosevelt wrote to Churchill in September '42, just before the landing, with the following words: surf on the Atlantic beaches is a calculated risk. So he was aware of the fact that it was a calculated risk. And I guess I was trying to do something to make it a calculable risk so one could do better than just hoping for good luck. Now the next slide shows what any Scripps students who might be here know one does. One makes a series of non-dimensional curves. This one shows the wave height h as a function of the wind speed u and the wind fetch f. And I'd gathered all the data I could find, and it's just totally inadequate, ridiculous. But the curves are drawn through it nonetheless, and it was one of the empirical curves we used for the prediction, GH over U squared. Well, anyhow, I was turned down by my commanding officer to work on that problem, and in despair, I telephoned Harold Sverdrup in La Jolla, said, please come out. I can't tell you why, but it's important. And he took the next flight, and we sat down in the Pentagon for a month and tried to figure out whether it would be possible to do a meaningful wave prediction. And we're desperate to see whether what we had worked out was any good. And we're looking for a way to confirm the prediction formula we had made. And we found that Pan American Airlines were landing their seaplanes in the Azores and had kept track of wave conditions in the Azores. We got a hold of the records and then did some what you call hindcasting, using historical weather maps to predict the wave conditions in the Azores where they were observed. And we're doing pretty well, but once in a while there was on the records a big peak in wave height which occurred, which we did not predict, very frightening. And I noticed that these spikes occurred at sort of equal intervals. And when we looked more carefully, we found that they invariably occurred on Saturday nights. And we decided it was more the result of Portuguese red wine than meteorologic conditions. Well, the Allied landing did take place in November 1942 in Oran, North Africa, during 2 relatively quiet days. I have to say, and I will come back to that, there was a lot of luck involved, but the days were relatively low. We then got authorization to start classes for weather officers here at Scripps, at La Jolla. And the only picture I could find that one of the students must have drawn is a cartoon of our classes here at Scripps. We had usually around 20 officers who would come for a period of a month, and we would learn as much as they did about the wave problem. And what happened usually is that at the end of the first month, we found we had to completely rewrite our teaching notes because we found so much was different than before. And that happened for each of the classes. I think we had 5 classes, and we graduated a total of about 100 meteorologic officers. And they are the ones who predicted for the amphibious landings in the Pacific theater of war throughout the Pacific War, and did pretty well. No great failures. There was a bad landing in Tarawa that some of you might have heard about, but it was due to bad beach intelligence. The incoming boats, LCVPs, hit a berm that had not been predicted, and the Marines had to jump in the water with 100 kilograms of things on their back and had to wade in the face of enemy fire into deepening water. And everybody then started working on improved beach intelligence, and it did not happen again. What's interesting is at the same time, there was a wave effort in Great Britain under Sir George Deacon, and some of the best known oceanographers of my generation were the ones who went through that wave laboratory in England. Longett Higgins is a professor here at Scripps now. Norman Barber from New Zealand was the first person to compute wave spectra. If there are any oceanographers here in the audience, they know that forming the spectrum of a wave record is the powerful way to learn about them, and it had not been done. Norman Barber developed a ingenious scheme for making that analysis. But the trouble was that our effort here in the United States was classified top secret. The one in England was classified most secret. Meant about the same thing, and it meant that we couldn't talk to one another very much. Well, anyhow, the most dramatic application of that work was for the landings at Normandy Beach. Unfortunately, I was not permitted to participate in the actual prediction. Two students that we had in our Scripps class, Charlie Bates and John Cole, did in fact participate, and it was a joint British-American effort. D-Day was on 6 June 1942. It was a case of sea and surf, not swell. It was locally generated by high winds, and the conditions on the proposed landing day were so poor that Eisenhower had to ask for a 24-hour delay. The next day, the prediction was difficult but not impossible, and Eisenhower decided to go in, realizing that a further delay would have meant a delay by 2 weeks because of the tidal conditions, and the element of surprise would probably have been gone. Eisenhower wrote a letter of resignation to President Roosevelt the night before the landing on the second day, in the case that the landing should be a failure. It was never delivered. Churchill gave a talk in the Commons on D-Day, later the day when the invasion took place, which was a very difficult one. Many people got hurt, but it was successful. And here's what Churchill said: Operation Neptune was the most difficult that has ever taken place. It involved tides, winds, and waves, with conditions that could not and cannot be fully foreseen. Well, I returned to normal oceanographic duties at Scripps, and I sort of promised myself after this was over, I didn't want to keep on working on waves. I had met a Chinese oceanographer who was doing a master's thesis many years ago on storm tides, and 40 years later, when he was retiring, he was still working on storm tides, and I didn't want to be in that kind of a position. So I played around with other problems, having a good time. Well, a few years later, Swell told me that unless I got my PhD, he would have to ask me to leave. So I quickly put together a couple of papers I'd done, wrote the shortest and quickest thesis in the history of Scripps, and got my PhD. And then a year later, it turned out the papers were badly flawed. But I have to tell for any Scripps students who are present that fortunately the University of California has no means of taking away a PhD thesis once granted. Well, a few years later, we were doing some work off Guadalupe Island off Mexico, just south of here, and with the Scripps ship Horizon. You see the location up here, and doing something totally different than working on waves, when we got an amazing record that showed a wave train coming in with the period of the waves getting shorter day by day in a very characteristic way. And you see, that is what happens because the long waves go faster than the short waves. So if you have a distant storm, you first get the long waves, and then by day, they come in shorter. And I think the next slide shows that picture. If you plot frequency against time, you get a set of high waves coming in, but from one day to the next, that period gets shorter. These started at 20 seconds, and a week later, we're down to 15 seconds. And now you can predict by a simple formula how far away they were generated from the rate at which the frequency changes. And when you made that very simple calculation, it came out at 13,500 kilometers. Extraordinary, because the Pacific isn't that big. And it was very, very troublesome. But it turned out there is just one possible explanation, that the waves were generated in the Indian Ocean, in the South Indian Ocean, in the southern hemisphere. You see my picture with Antarctica, Australia, and that they came by Australia and New Zealand to get into the North Pacific. This is a chart where great circles appear as straight lines. Now, it turned out that Norman Barber, whom I had mentioned before, who'd done the first spectral waves, had discovered on the beaches at Cornwall, yes, that he had received waves from the South Atlantic at distances of 10,000 kilometers. And so we wondered whether, in fact, these were waves coming from a very long distance from the Indian Ocean. And the obvious way to check is to measure their direction and to see whether they come from the narrow window between 220 and 235, which is the only possible way to sneak out of the Indian Ocean. And so Norman Barber joined us, and he and Frank Snodgrass, with whom I worked for 30 years, was a wonderful engineer. We built a direction, the next slide is fine. We built a directional array that we installed on the western shore of San Clemente Island. San Clemente Island, if you recall, is offshore here. I think it shows a picture showing the island. And the directional array was built by having a triangle of wave recorders. And if you have one here and here, and the wave comes in at the same time, then obviously the direction is such that the crests are lined up with the direction of the recorders. And we found that the waves did come in from the required narrow window, 220 to 230 degrees. And so it was proven that these did come out of the Indian Ocean and entered the Pacific through the window between Antarctica and Australia and New Zealand. Well, having learned that, we couldn't miss the temptation of having an expedition shown in the next slide. Oh no, I wanted to mention that these directions were so well determined and the distance so well determined that we could pinpoint, or at least locate, the area of the storms. And there were very poor Southern Hemisphere weather maps, and we decided to augment these using the information from the waves taken 15,000 kilometers away to help construct a remote weather map in the Indian Ocean. And this one I want you to remember, because I will get back to it at the end of my talk. This one was a storm centered at an island called Heard Island, 14,000 kilometers away from San Clemente Island. Somebody had sent us a study that had been made contouring the height of waves all over the world, and they peaked in the South Indian Ocean in this area, the highest waves in the world. Well, the next expedition then was trying to have the fun of following the waves. And if you could show the next slide, please. Here is the expedition we called Waves Across the Pacific. We occupied 6 stations: New Zealand, Samoa, then an uninhabited island on the equator called Palmyra, then Honolulu. Then, in the absence of any islands in the North Pacific, we used the newly commissioned ship, Scripps ship Flip. And finally, the one volunteer, the one student we had in our group volunteered for Yakutat, Alaska. So that, and that was kind of a fun station. I volunteered for Samoa. And it was a very interesting organization. We had, oh, this shows Samoan, so please leave this on. You can see how we were suffering. I took my two daughters, age 4 and 6, with me, and we had picked the sites, just looking at charts, trying to find areas that are well exposed to waves. And we'd chosen this island in American Samoa and written a letter to the High Chief Satele, said, could we stay with you for 3 months and do an experiment? And there was no answer. And then 6 months later, I wrote Satele again and asked whether we could come. Still no answer. And it was with some apprehension when we landed on the weekly flight to American Samoa in Pango Pango, and we had not heard a word. But when we checked in the Rainmaker Hotel for the night, I was told, well, the High Chief has been waiting for you. And there he came and said, yes, we built a special folly for you. The village where he lived had no running water, no electricity, but they'd built a house out of bamboo, and it was absolutely wonderful. And the man you see playing the guitar was actually worked for the wife of the High Chief, and it was assigned to us to make us happy. So it was, and when I got to know the High Chief better and asked him why in the world he hadn't answered my mail, he said, how can you question the known hospitality of the Samoans? You should never worried. And we had sent a kerosene icebox so I could keep some milk for the children. And as soon as that arrived, I hadn't realized there's an ancient Samoan law that the High Chief owns everything in the village. As soon as it arrived, he said, oh, how wonderful, I've been waiting to keep my beer cold. And promptly filled it up with beer. That was how things stood for 50 years. We did the recording at those 6 stations with 8-hole paper tape, which was the technology of the time. And when I showed that to a class the other day and said it was the latest digital technology, everybody roared with laughter. But that was at the time the best way of making. Somebody here in the audience who ever used 8-hole paper tape? Oh, wonderful. Well, next slide shows that there was a little problem. These black dots show the locations of the storms that we had made using the directional array at San Clemente Island that I mentioned. And we recorded for 3 months, and this shows the location. Notice that there are 2 locations on Antarctica, on land, which is slightly bothersome. And we chose to ignore that. That was, you know, the exceptions that prove the rule, or whatever that silly proverb is, and just say, well, we got 28 right and 2 wrong, so that's all right. But it was slightly bothersome, and it stayed that way for 50 years until Bill Young, who's in the audience, Scripps professor, and his French postdoc, Basile Gallet, who's also in the audience, started working on the effect of current shear, vortices in the oceans on wave propagation. You're a little bit too early. You're giving away what happened. So go back. And found that waves are significantly bent, significantly change their direction, going through areas of considerable current shear, or vortices. Did the theory, And then Basil went to a program called OSCAR, which is online now, which gives the surface currents all over the world every 5 days, and actually calculated what would happen to a wave system under those conditions. And the next slide shows what happens. A great circle route is shown in dark brown, and what we found is, and the scattered arrival, as I mentioned, might go, as I show by this line, and changes direction as plotted here at the equator and comes into San Clemente Island as shown. Now, if you work backwards with the direction that's recorded and do not take into account the scattering at the equator, you would end up along that dashed line, and you would place the storm, the source, on the continent. So we have that very nice explanation after 50 years, and I would have not come to speak to you tonight if I wasn't encouraged by the fact that this development has just taken place, and so that can take away the very bothersome two things that did not work. Another thing that Basil learned that seems to me is equally interesting is that there's a high variability in the currents. They may be very different 5 days later, and neither the variability nor the current bending is taken into account by anybody or by the predictions that I started to tell you about early in the talk. And so there must be times when the vortices are just developed the right way to focus things. And maybe that explains that once in a blue moon, you get enormously high waves. I remember one time when we had 20-foot breakers at the Cove, but it happened only once in 20 or 30 years. So think of it that as the waves propagate north and go through the various currents, if conditions are just right, they may produce some very unusual wave conditions. We're having fun in how we're going to report the change, that the new developments that we owe to Bill and Basil. We had published our work on San Clemente Island in the oldest journal in the world, the Philosophic Transactions of the Royal Society, and they permit you to send in what they call a corrigendum. Usually you send in saying, I'm sorry, but paper I published last year said 25.67 instead of 25.76, that kind of thing. I got permission from the editor of the Philtrans to send in a corrigendum which starts saying, in a previous paper, even if it was 50 years ago, we refer to two sources located on the Antarctic continent. When allowance is made for refraction by the equatorial current system, the two troublesome source regions move offshore. My co-authors, the co-authors 50 years ago, Frank Snodgrass and Norman Barber, have died, but they will be glad to learn that the Swell did not originate on the Antarctic continent. So we're getting ready to send that in. And as I was saying before, modern wave predictions neglect the current shear, they neglect, more important, the variability that is associated with it. And looking back now to our predictions of World War II, I'd like to sum it up with a single sentence. What we called predictions were lucky extrapolation of inadequate data. Lucky extrapolation of inadequate data. What is special about the prediction days during World War II is, of course, that people's lives were involved. And I'm very proud of the quote by Blair Kinsman in his book on wind waves, saying there are some thousands of World War II veterans alive today who would have been dead in the surf had Swell and Munk not done their best with what they had. Let me close this talk with a few minutes of discussion, ending with a brief account of a visit in 1991, 32 years later, to Heard Island with some unintended results. The next slide shows what we were doing in Heard Island, which is located here. We had worked with acoustic waves, ocean waves, and wanted to do an experiment of how far away from man-made acoustic loudspeakers could you still receive a signal. And wherever you see the red point, somebody had lowered a hydrophone into the ocean to see whether we could be heard. And the blue lines are great circles again, along which the sound waves. This time I'm talking about sound waves, not ocean waves. And you see there's one propagation past the Cape of Good Hope that ends up in the South and North Atlantic. And there's one going by Australia, New Zealand, up into the South and North Pacific, very much along the line along which the ocean waves travel. And we found that our signal could be, in fact, received globally at distances up to halfway around the world. And the difference being that from Heard Island to, in this case, Seattle, sound waves took 3.5 hours, whereas the ocean waves take 10 days. They're slower. Anyhow, when we did the experiment at Heard Island, I had forgotten that 32 years earlier, we had, in fact, plotted a weather map over Heard Island, inferred from the waves that we were recording at San Clemente Island halfway around the world. And that had a reality only that there were little peaks on a piece of paper that were recording these waves. And they had about as much reality to them as I suppose an astronomer has for a star that he's observing through the telescope. We'd forgotten about that experience. And so we sailed out of Fremantle, Australia, into the Indian Ocean, and 2 weeks later came to Heard Island. And there is this snow-peaked mountain covered by snow all year round. Has been climbed only once. I found that interesting. And you see in the foreground huts which are used by biologists, Australian biologists in the summer. The island is uninhabited, and a wonderful view. And we started to set up to transmit our acoustic signals through the man-made underwater loudspeakers. And a week after starting our transmissions, we ran into a storm, and we had eight loudspeakers heading from our vessel. One was torn loose and went to the sea floor, and I sometimes get asked, how long did we ever have an instrument on the sea floor? I can say 20 years, and getting longer by the day. And I watched with horror when each out of the other 7 speakers failed at minute intervals. And then suddenly it occurred to me with a flash that we're here, we're there, where the swell begins. Thank you.
So the question is, what type of trouble did you have with environmentalists when you created the sound underwater?
Yeah, we had a very difficult time, and we've never overcome it. They were legitimately worried that our sound sources would harm the whales. We think they do not. And they have a certain principle which is very difficult to argue with. It's called the, what is it? It's not the uncertainty principle. It's some principle that says that if you don't know everything there's to be known about something, don't do it. And it's a good recipe for doing nothing. And but we have been transmitting sound for 20 years, and we have learned something.
Howard, trivia question. Why didn't you?
I don't know.
So the question was, why didn't you go to Western Samoa? Yeah, rather than American Samoa, because the weather would have been better? The whole experience would have been better.
Yeah, I don't know. We did look at island charts and picked a site where we could run a cable right down from where we lived into the water. What we actually recorded was pressure on the sea floor at a depth of about 100 meters. And so we wanted islands with steep sides. And we had some problems, but it was a wonderful site. We had a great time at Samoa. And the funny thing is we ran a cable down like we did at each of the other stations and put in a recorder and ran the cable up, and we had a certain amount of slack left, which we then put on a figure 8 on land, and then got into the folly where we actually had the 8-hole tape recorder. And Honolulu had a funny thing happening. They came down one day and the cable had deteriorated, and they found that somebody had built a fire on the cable. And so we received a message saying, be careful that nobody builds a campfire on the cable. And I went to my high chief, Satele, and told him about it and said, would you mind if we put out a sign saying no fire? He said, oh, I would mind. My father is buried there, my grandfather is buried there, my great-grandfather is buried there. No one would dare to make a fire on the burying grounds of the Satellas. And then he waited a second. He said, better make a sign saying no fire.
So the question is, have you found any effect of the temperature in the air on the sound waves in the ocean? Is that correct?
Have you had any insight to the warming of the Earth from your sound wave experiments?
Any insight into the warming of the Earth from your sound wave experiments?
That's a very interesting suggestion. We had a student here, PhD student named Brian Dushaw, and he has proposed to do one of two experiments over again. Actually, a previous long-range transmission from Perth, Australia to Bermuda, which is about antipodal, if you look at a map. And that was done in 50 years ago, whatever that is, 1960, by a Columbia geophysicist named Morris Ewing, very famous. And it was done in days when people weren't so worried about planning things ahead of time. Some people were doing some seismic exploration off Perth Island. And he says, and he sent a message saying, looks to me like there's a direct view from Perth to Bermuda where I'm, why don't you guys drop in a few sticks of dynamite? See whether I can hear you. And they dropped in 100-pound sticks 3 times, and the signal clearly came to Bermuda. Took about 3.5 hours. And Brian Dushaw's suggestion is to do this over again. And if you accept what we have learned about ocean warming, and warming means that sound goes faster, the transmission should take 10 seconds less. And he thought, what a wonderful experiment to put into a single number the effect of global ocean warming. It's global because you're going halfway around the world. And 50 years ago was the beginning of the Industrial Revolution. So in one measure, you would have, by these 10 seconds, an indication of global warming. The problem is that they didn't do very careful navigation. Yes. And there is some question whether you could do the experiment well enough to know that what you're seeing is a change in time rather than change in position.
Wouldn't it be better than the previous one?
Now, we suggested they do Heard Island over again, where of course we had splendid navigation, and that may happen. It's been proposed, and it may happen. I think it'd be a great experiment, and it could be used by future generations 50 years from now to see how much things have warmed.
It's getting warmed up.
But I do not know of anybody who has done it up to now, but since you asked such an interesting question, I hope very much such an experiment will be done. We did GPS from ships, but I don't know whether you asked for a certain reason, but GPS was canceled because of some political event. And we had to go back. It was put out of commission. And I forgot what happened.
Oh, so the question was, in 1991 in Heard Island,
Yeah.
Did you use...
Oh, we had GPS, and then after we left on the way home, there was a brief period when no GPS signals. No, but we do have good navigation. And if Heard Island were done over again, it probably could be done. And there would be, I think, a measurable change in travel time because of ocean warming.
Well, Walter, thank you very much for insight into the past and ideas for the future. Thank you so much.